Hello and welcome back to another video on Stat 305 for regression analysis. Today we'll be going over my homework, my graded homework 2. And in this homework we go over various exercises and theoretical exercises as well involving MLR, multicollinearity, ridge regression, OLS estimators, skewed data, and data with just noise. Um, I feel like the most important thing in regression analysis is being able to interpret all kinds of data. As general as that sounds, I feel like it's very important to interpret things appropriately. And I feel like, as a somewhat of a statistician myself, I feel like it is my duty to interpret these values and meanings, whether simple or complex, and make it so it's easy to understand. And, I feel like humans naturally look for patterns all throughout life, not just statistics. Whether you see someone, you might recognize their face. Do I know that person? Do I not? Is what I'm doing safe or is it dangerous from just previous experiences? So I feel like that's very important. And my understanding throughout this course has went from I was like a confused dude who, struggled with concepts of SLR to someone who really like understands SLR, MLR, polynomial regression, model selection, all these different types of things that I feel lucky to learn, and I feel like I thrive in this class because it's a class that really rewards you based on your ability to learn. And so yeah, we're gonna get right into my answers. So all right, so now I will share my screen. Here we go. Yes. Okay. So, all right. So, something important I think I found in the theoretical exercises was the ridge estimator, ridge regression. So, ridge regression really is a good representative of the bias variance trade-off. And when there's high bias, the model is prone to oversimplification. And when the model is oversimplified, it doesn't find significant patterns or has trouble finding significant patterns. While on the other hand, when the variance is high, the model is, overfit, and it's tough when when the model deals with other data sets because it might not fit that data set particularly well when like as compared to the first one it was modeled after. And yeah, I feel like ridge regression does a great job of this, showing this trade-off because ridge regression increases the bias, it increases the bias and um, it decreases in turn, it decreases the variance, and because it shrinks the coefficients and this means when comparing it to other data sets, it will when comparing it to other data sets, um, the data may seem or the model may seem more stable and there won't be as much, variance and it will overall fit the model better. So yeah, share my screen. Okay, pause, stop share. All right, so excuse me. One thing I found that was really surprising in my applied work was kind of all of exercise 5 about how you could have two independent matrices and find some sort of correlation with them, even though they're all just noise. Now I understand it, but initially I was surprised, and I feel like it's something important that statisticians should know and how apt false interpretation like really is. So like with the like if when we're doing best subsets model selection, we're looking at a bunch of different predictors and the combinations of all these predictors together, and you know it just picks like best subset just picks the best model when considering all possible combinations of predictors together. And in this case, we came up with a BIC model of just size one. This makes sense because, since the data isn't like it's just noise, the best representation would be just with one predictor. And, you know, it had a really low R squared as well. which means that the data didn't really explain like the X's or like the predictors didn't really explain the response variable that well. And it's just baffling how what like when some predictors seem significant, how how meaningless it could actually be just due to like false correlations and exploiting noise. I feel like it's important for statisticians to know like data dredging and to be careful of, these false positives because it could really cause for dangerous interpretations and, dangerous consequences in the real world. So, yeah. So, share my screen again. Okay, so I chose BIC to be my champion model because of the best set or the best test set for the RMSE. AIC, always tends to overfit the model, and in this case, BMS underfit the model. Um, and AIC, as we know, AIC commonly at times it prefers more predictors than few because it focuses on the precision of the data itself. And this means in some cases it might chase the noise and is prone to instability, while BIC, tends to find the true model, avoids noise and removes irrelevant predictors. BIC favors a simpler model um, as compared to AIC. And again, this comes back to the bias variance trade-off, which again is very important. Um, and it shows that not all the time how more complex models aren't always the answer, and how when we simplify things, uh, true insights are shown, and we can make better conclusions as a whole. And for this reason, BIC is my champion. Finally, I'm going to end with a few things. So starting off, my most challenging unconquered peak, I feel for myself, it's been a pattern throughout this whole class. It's got to be the theoretical exercises. You know, I mean, even in this assignment, I do feel like the theoretical aspects have really shown why they're important. And like for example, the ridge regression, I feel like looking at the data matrices and how the coefficients shrink, I feel like I really gained an understanding about um, the whole bias variance trade-off and why it's important to regression. An enjoyable concept, I'd say that enjoyable concept I've mastered, in this class, I feel like is MLR. And the reason why I feel this way is because when I first learned SLR, it was still kind of confusing to me. And then when I got to MLR, I feel like SLR felt so much more simpler. And I feel like almost learning the concepts of MLR and how like complex it can be compared to SLR kind of made SLR make way more sense to me. And when mastering MLR, I feel like I really understood what like this is where I really learn how to interpret data efficiently and appropriately. Um, for this assignment, I feel like I deserve an A. I went to, I put like my blood, sweat, and tears, I feel like, into this assignment. Me and my brother started this assignment about 3 weeks ago, and I'm just now finishing it. So, yeah, I've been to a couple of the office hours, and I feel like this shows my dedication to this class and to this assignment. I really try to learn, and I feel like, in this class we are rewarded for actually showing that you understand and expertise in these various areas. Yeah, so I feel like regression has changed the way I think about data. Very, I feel like regression has changed the way I see data in the real world. Very, big difference. I feel like I think about things more like mathematically now. Like for example, I was at a soccer game, one of the RIT soccer games, and I thought I could probably make a logistic regression and mathematically predict whether or not a player's going to score given, how many players are between the ball and goal, you know, shot distance, whether it's a free kick or a penalty, all these other like factors that allow me to predict a certain outcome. I see it all mathematically, and I feel like, you know, being in this course is, a privilege, and I think I'm very lucky to take such a course because I feel like I see a lot of things mathematically now and not just, oh, like I'm just watching a soccer game, and, very grateful. And yeah, I had a lot of fun with this assignment, and I think I learned a lot. And I think it also has taught me as a whole to, a lot of things on the outside, not just math. I see it everywhere. So yeah.